So one is safety. So we know how to select glass based on the application, based on the location, and then how to test the glass. What are the test procedures available, or what are the kind of test available to go through it. So once the safety is done, then I have to move on towards the energy or the sustainability. So how can I make my building more energy efficient or sustainable? Yes, there are options available. In fact, NBC starts with a very clear note saying the glass selection has to be done based on the location. For example, there are different kinds of glasses available in the market. It has to be precisely selected based on the climatic conditions. In fact, ECBC very clearly defines 5 climatic zones, and based on the 5 climatic zones, how the glass selection can be happen, which I will take you through. So there are key parameters which is going to influence the overall heating load or the cooling load. Ideally in India, we are much worried about the cooling capacity or the cooling load of the building which is inside. So the important parameters which are going to influence that, the first parameter which we call the solar factor, which is the direct heat transmission ratio for a glass. So as I said, for a clear glass, it has 83 to 85% of transmission. So how can we minimize this impact? You cannot reduce the source value. You have a glass, so there is a possibility of the heat entering into your building. So how can we, what are the choices that we have to minimize this heat coming into your building? The first choice will be, if there is a possibility, playing with the orientation of the building. Because traditionally with the sun path understanding, you can identify that the east and west of the building has more impact compared to the north and south. In fact, compared to south, the north even became a negligible direction for the sun to penetrate. So is it possible for us to play with the glass area or the orientation of the building as such, so that the amount of heat coming in can be reduced? Second one important parameter is the window wall ratio of the glass, window to the wall ratio. So what is the percentage of window compared to the percentage of your wall? So NBC says from 0 to 40% in case of prescriptive, or anything more than 40, even up to 60-65%, it has to be as per prescriptive. So the challenge is which direction I have, what is the window wall ratio. Based on the window wall ratio, what is the kind of product we are going to use so that the amount of heat coming in is going to be reduced. Is there possibility to have a shading device, which is a permanent shading device, which can reduce the amount of direct heat and light to an extent which is going to enter into your building? Or finally, the property of the glass, as I said, what is the light transmission, what is the solar factor, and what is U value of the glass. So to again recap, to influence the amount of heat coming in, the key factors influencing the solar heat gain is the orientation, which is ideally you have to play with the east and west to north and south. So you can try to place the building more towards north and south than towards east and west. Then the window wall ratio, what is the percentage of window wall ratio respect to the orientation. Then is there any possibility to have a shading device so that it can help you to cut the heat coming in. And the fourth important parameter is what is the performance of the glass going to be used in the building based on the purpose or the occupational pattern. Second one is, what are the other options that we can do to reduce the solar factor? One is, I can play with how to reduce the heat coming in. There are some provisions available. Okay, I have a restricted orientation, or I need a particular window wall ratio. I am not able to have a shading device. Still, I wanted to reduce the heat coming in. Then I have to play with the solar factor of the glass. So what are the things that I can do in reducing the solar factor, which is ideally going to cut the heat coming in from outside to inside? The first option is, you can use the coatings, the reflective coatings, whether it can be an online coating or an offline coating. But the current generation offline coating has a lot of generations has developed, and it has a very precise numbers or a precise solar factors can be achieved based on the type of building. So ideally you can use reflective coating, which can be again used in an insulated format. Ideally it's called double glazing unit. So you have an outer coated glass, you have 12 mm air gap, and you have an inner clear glass. So which helps you to disconnect the solid member so that the amount of heat transfer has to pass through a solid and then a vacuum and then a solid member. So it helps you to reduce the percentage of heat transferring from outside to inside. So option 1 is your coated glass, which helps you to reduce the solar factor directly because of the coating you use. Second one is, use it in a double glazing format, which can help you to reduce the heat to a certain extent. Or the third option, which we can use inert gas into the airspace medium between the two glasses, which can further delay or reduce the amount of heat transferring. So option 1 is to this content is we need to identify what is a possibility as a designer or as an architect or as an engineer we have in selecting the glass. So first option is to identify how to reduce the heat coming in by changing the overall the aesthetics of the building. Here I mean aesthetics is orientation, window wall ratio and your shading devices. If I cannot play with that much, my plot sizes, or I have a constraint on the plot size, I cannot turn around the building, or the plot itself are quite rectangular and I am not able to turn it around, then that case then you have to have a huge impact on how you are going to reduce the solar factor of the glass. So the options available again is you can have a coating on the surface of the glass. You can in fact use tinted based coatings which will help you drastically reduce the solar factor. Second option is you can still use this in a double glazing format. So you have an outer coated glass and an inner clear glass with an air gap. Third option is the air gap can be filled with an inert gas. So there is 3 options for the buildings to address. There is 3 options in the glass to reduce the solar factor. So what this code trying to convey? It says by controlling the thermal heat transfer using the right solar heat gain coefficient or solar factor and the U value of the glass, the cooling load can be reduced and hence result in a huge energy saving for the overall building. They are saying instead of allowing more heat into the system and then trying to optimize the efficiency of the cooling system, there is an provisions available. You can play with the type of the glass or you can type with the orientation of the building to reduce the amount of heat coming in, which is going to impact the overall cooling system. Second important parameter is the functionality of the glass to harvest more daylight. Moment we harvest more daylight, there is a critical point for it which we call the glare. So when the amount of light coming in is extremely higher, which is more than what I needed for the particular occupancy zone, then it becomes a disturbance and it becomes a glare. So the ideal or minimum or optimization in the light transmission is very important. So based on the window wall ratio of the building, based on the floor plate of the building, we need to identify what accurate visual light transmission is required for the facade glazing, so that the amount of light that coming in has to be distributed fairly in the entire floor plate area without creating a glare into the boundary area. So there are concepts like you can have a daylighting devices or daylighting paints which can help you to have a deeper penetration of the light without disturbing the overall comfort of the occupant. So to do the glazing analysis or to select a proper glazing, we can, in fact the NBC has very clearly given a direction how can we select glass. So today with the modern tools available, we can do a simple building orientation analysis, we can do a sun path analysis, we can do a side shadow analysis, we can do a solar exposure analysis, even the daylighting analysis, which helps you to identify the directions which is more vulnerable, angles which are very vulnerable, or the number of days in a year which we need to address that as a constraint, or based on the kind of a building or the neighboring building and their impact over the building. How can we get the benefit of the neighboring building shadows? This can be precisely understood with the current tools technology, I mean the technology which is available with the tools. The detail about these tools can be used, we will be covering it in another section, which is called the design tools. So even in this solar and daylight, you have tools which helps you to understand the heat transfer ratios, and you have a daylighting tool which understands to help you to calculate the lux level on your entire floor plate or at our working table height or the tabletops. The both will help you to understand what is the bandwidth of products that you have to select for satisfying both the light demand and the energy demand, which again the both has to comply your energy efficiency code or has to comply as per the National Building Code. So just to take you through what is covered in Energy Conservation and Building Code of India, which is recently revised in 2017. So the basic difference version from the current old to the new version is, the old version has only one kind of a building where you can do it as per prescriptive or you can do it as per simulation. Under prescriptive you have a trade-off. So the new template which has slightly been upgraded. So in fact in this you can design the building as ECBC or ECBC plus or super ECBC building. Ideally you can improve the energy efficiency of the building by just doing simple measures which is covered in your ECBC. Specific to the glass, so based on the different category, they have even given what has to be the precise requirement on lighting and the precise requirement on your solar factors. So the lighting, this time we are working on the UDA, which is ideally called useful daylight illuminance, which is ideally between a particular bandwidth of 100 to 2000 lux. So what we do is, I have a building and I have a particular window wall ratio. When I have a glass with very high light transmission, when I do the daylighting calculation, the percentage of area above 2000 is not considered. The percentage of area below 100 lux is also not considered. So I will be calculating very precisely, which is a comfort zone between 100 to 200 lux. What is the percentage of area in my building for the whole year? So ECBC says, for an example to a business or an educational building, if I have to comply a building for ECBC, 40% of the floor area has to have the light transmission between the range of 100 to 2000 lux. If I have to make my building more efficient, more naturally littered, which is called ideally the ECBC plus, in that case I have to comply this for 50%. How it is possible? Just by increasing light transmission, it is not possible. If I increase light transmission, then it will increase the percentage above 2000, which is not a solution. So in this case, I have to play with the design precisely, whether I can divide the vertical facade into two as a daylight and vision pane, or I have a light shelf which can penetrate the light deeper. So the third category, which is called the super ECBC building, which I have to achieve 60% of the floor area with 100 to 2000 lux, which is called the UDI for the whole area. I mean, then I have to precisely from the day one when the building design, my intention has to be, I am going to make a super ECBC building. So the intention to satisfy or to make three different types is, one is with the basic design or the confirmed design. We can make simple alterations to the product selection and you can make the building energy efficient. Or the next step is, we can introduce some kind of basic accessories like your shading device or a daylight paints to improve the efficiency. The third category, which is a super ECBC, ideally from the day one, from the design phase, it has to be done. Otherwise, it's not easy to make a building super ECBC. So then on energy, what is recommended as per ECBC is, you have U value requirement, which is ideally 3 watts per square meter degree Kelvin, and for the solar heat gain coefficients for the non-north areas, up to for the standard ECBC buildings, the solar factor requirement, minimum requirement is 0.27. Lower the solar factor, it's going to be a better building. Similarly, for based on your orientation, you can understand what kind of a compromise you can do it on your solar factor, which is very detailed out in your energy conservation code, and it has 5 different climatic conditions. So even sometime based on the climatic condition, you can play with or you can compromise the solar factor values. Similarly, to achieve ECBC plus or super ECBC buildings, in case if you wanted to do in the design stage, then very precisely the code says the solar factor has to be less than 0.25 for the non-north direction orientation, see south, east and west. Similarly, you can play with your solar factor for north or based on the kind of a location. So the 3 important parameters that actually covered in ECBC, which has reference in your NBC 2016 is the solar factor requirement, the U value requirement and the light transmission requirement for 3 different types of building, which is the basic ECBC, ECBC plus and super ECBC. As I said, to make a building ECBC, we need to address or we need to find proper energy efficient materials so that the current design we can make it as an ECBC building. Whereas if I have to make ECBC plus, I have to do some kind of a trade-off. It can be on the window wall ratio, it can be on the shading devices, or I have to introduce something like daylight shelves, or I have to introduce something like high performance glazing, which has a higher selectivity to make the building ECBC plus. If I have to make super ECBC building, then it has to be start from the day one, starting based on the orientation. Even orientation wise, the window wall ratios can be played, or orientation wise different products can be used to achieve or to make the building as super ECBC buildings. There are some kind of suggestions also been given in the code, which helps you to make the design in the basic stages itself to make it more ECBC compliance. They're saying ideally try to make your window wall ratio in the ratio of 0 to 40 or 40 to 60 in this two bandwidth, so that you can play with the materials to make the building more energy efficient. Or you can use the shading devices, which ideally have a huge impact on your overall light and heat coming in. As I said, orientation, or we need to play with the light transmission of glass to control the external lighting level with the inside lighting level requirement, or we can use shading device or daylight paints to harvest more, or you cut the light. So either or options.